and look at benchmark percents. And then we're going to try to get to estimating, but first period we didn't get there. That's why we changed it. So we don't have any homework set for tonight, but we are going to do the in-class percent estimation for today. Go ahead and open up in your modules to page 271. So there are, again, your learning goals. Our first thing we're going to do, we're just going to do some quick computations. Compute each product. It's just a fraction times a whole number. We just want you to see how well you guys can do these quick computations. We'll give you like 2 minutes. Go. Okay, as it's a short day, so we're going to go kind of quick on some of these. But our first one, anytime I have a whole number and a fraction, first thing I need to do is make them both fractions by putting the whole number over 1. Which means I'm just now taking 350, dividing by 10, which is going to give me 35. Kind of the same thing on number 2. So now I have 350. It's over 1, not 100, sorry. I'm getting ahead of myself. 350 over 100. So that's going to simplify down to 3 and 50 over 100, which would be 3 and 1/2. Our next one is going to be over 10. Gives us 670 over 10, or 67. And then the last one is going to give us 670 over 100, or 6 and 71/100ths, or 6 and 7/10ths. Questions on any of those? Should be pretty easy, guys, when we're dealing with tens and hundreds, which is part of what makes percents so nice to use, because it's dealing out of hundreds. Yes, sir?
So when we do this kind of math, after we figure out the answer and if we get a decimal, can we put a percent instead?
As long as you move your decimal twice. But I normally wouldn't put percent unless they've specifically asked for it. You gotta be careful and make sure you're answering the question the way it's been asked. Just like the one from our warm-up, where if you answered in minutes when they asked you for hours, you would have been only given half credit, right? Half credit is still an F, right? I get an F when it's easy to get an A. All you gotta do is make sure you give the answer in the correct format. Okay, we didn't do number 1, so we're gonna go down to number 2. Noah and Dylan were assigned the numbers 600ths with repeating decimal and 1/10%, but they disagreed on which was larger. Noah says that 600ths repeating is less than 1/10, so 600ths repeating is less than 1/10%. Dylan says since 1/10% is the same as 1,000th, and 1,000th is less than 600ths repeating, 1/10% is less than 600ths. Who is correct? Explain your reasonings. We'll give you guys a chance to talk at the table on this one. Figure out who is going down the right path in what they're thinking. Okay, raise your hand if you think Dylan was correct. 2 of you. Way to be brave. How many think Noah is correct? You think Dylan's, you're joining the Dylan side? Okay, why do you think Dylan's correct?
0.1% equals 1,000. So, to the decimal, you have to move the decimal point twice to the left.
Okay, so he actually changed the percent to a decimal so that they could compare the same format, right? Did Noah actually convert the percent to a decimal? No, he just dropped the percent sign. Can I do that? No, percent means something, right? Percent means what?
Out of 100.
Out of 100. So if I just drop the percent sign and don't change the number, I haven't done it correctly. I mean, that was kind of what we did last class, right? How do I change a percent to a decimal? I move it to the left twice. So if I move to the left twice, empty buckets get a 0. As a decimal, that is 1,000th. Right? Okay, so Dylan is correct. My reasoning would be Noah didn't convert the percent to a decimal. So why is this important? Because in order to make comparisons, I need to compare the same things. If they give me a percent, is it easy to make it a decimal? Yes, I literally just moved the decimal twice to the left, guys. So in order to do a comparison, they either need to both be decimals or both be percents. Once they're the same format, then I can compare, which gets us to our number 3. Number 3, we're going to order the numbers from least to greatest. But they've given us 3 different formats. They've given us decimals, they've given us fractions, they've given us percents. From our example we just worked, your key is I need to have the same format. So I will be honest, the easiest way, turn your fractions and percents into decimals. Once they're all decimals, you should be able to order them. Make sure you order them in the correct order. Now, there are several things that you have to go through here, so we'll give you guys about 7 minutes to get these in order. Remember, convert them first, then compare them and put them in order. You may work together as a table, but try to do as much as you can by yourself. Go ahead and get started, guys. So bottom line on this is basically you understand and it went pretty quickly, or you're really struggling, in which case let me show you again how to do these. Again, the key is we have to have the same format in order to be able to compare. So my recommendation, turn them all into decimals because it's the easiest one to get all of them to. But as long as you did it in the same format, you should have been okay. 1/9. This one I just have to divide. Remember, the winner's on the top, the loser's on the outside. That goes in one time, and you should see a pattern very quickly, right? So this is going to be the same as 1/10 repeating. 17/20. Your other option, get to an easy bottom where it's a power of 10 or a power of 100 to help you understand where it is. In this case, I see that 20 will go to 100 very easily. I can just multiply by 5. So that's going to give me 85 hundredths, or 85 over 100, which I can then turn into a decimal because that's my hundredths. 95%. Percent's the easiest because all I'm doing is moving my decimal twice. Same thing on this percent, moving my decimal twice. 3/8. Now I have to divide again. So 3 divided by 8. That's going to go 3 times. Gives me a 6. 60 is going to go 7 times. Gives me a 4. Still not at 0, so bring down another one. 5. Now I finally made it to 0, so that is going to be 375 thousandths. 70%, I'm just moving twice. That becomes 7/10. 4 3/10%. I'm moving twice. Don't forget, empty buckets get a 0. So that becomes 43 thousandths. The other ones are already in decimal format. Once I have everything into a decimal, now we're ready to start putting them in order. So I go through. The first one should have been really obvious, right? What's the smallest number in our list?
1, 0.
0. After that, now we're going to start going through the place values. So I'm going to start looking in the 10th place. So if I look in the 10th place, that's a 9, 1, 8, 9, 2, 3, 7, 0, 8, 6. So the smallest one is 4 3/10%, because that had a 0 in the 10th place. Okay? Then I go, the 1, I have a 1 in the 10th place, so that's going to be 1/9. Another key, even though I've changed them all to decimal, how am I making my list? By the original numbers, right? So the decimals help me compare the list, right, Samuel? But I still need to make the list by the numbers they gave me. Another little hint, as you're doing them, I would actually make a slight tick mark to cross them out so you know which ones you've already done. So that was the only one with the 1s. So now I go to the 2s, that's 25%. Then I've got a 3 with 3/8. Then I've got a 4. No, I don't. A 5. a 6, so 64 hundredths, a 7 at 70%. I have 2 eighths, so 81 hundredths is going to come next. Then 85 hundredths, which is our 17 twentieths. Then I've got 2 nines, 95%, and 99 hundredths. Now, guys, anytime you make a list, highly recommend doing a simple count to make sure that you got all of the numbers. So if I go back through, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. In my answers, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I did it correctly. Just as an FYI, last period, I actually missed a number. I forgot to put the 95% in and didn't realize it till I counted my list. So please, did it take long to do that count? No, but it can make a world of difference. So please, just do that quick count anytime you're doing a list. Any questions on where any of those numbers arrived in our list? How many of you got all 11 of them in the correct order? 4, 5, only 5 people? 5 people got all 11 in the correct order? Okay, good job for you 5. The rest of us, we got a little more work to do. Can I pull out your highlighters or marking pencils, something to mark your text? We have a definition that we need to add to our vocabulary. Samuel, really? As much as I would love to share with Facebook the flower in your hair.
You got caught on YouTube.
Okay, guys, here's our definition. We have what are called a benchmark percent. These are our commonly used percents. Here are some of the numbers they give us. 1, 5, 10, 25, 50, and 100. So these are what we call benchmark percents because it's very easy to convert from one to the other based on their relationships. We can also use these to calculate any whole percent of a number. So by understanding the relationships, we're basically able to do this math very quickly, is really what benchmark percents boil down to. Because once I understand the baseline and the relationship, you can find the new numbers. So we're going to use our tape diagram. We're going to work together on this one, mostly because of the shortness of time, because it's a Tuesday. And we're going to use the tape diagram to state each relationship. So how is 50% related to 100%? What is the relationship between 50% and 100%? 1/2. So I'm going to go the other way. There are 2 50% in 100%. So as I said, if I have 100%, I can just divide it by 2 to find what half of it, or 50% of it would be. How is 25% related to 100, and how is it related to 50? So we have 2 relationships that we're going to talk about. Looking at my tape diagram, what do you see there? Anthony?
25 goes into 50 2 times, and it goes into 100 4 times.
Okay, so there are 2 25% in 50%, and 4 25% in 100%. Hopefully, guys, this is common sense. You're kind of seeing this very easily. If not, hopefully the tape diagram picture helps you understand what we're doing. Now let's look at our next one. How is 10% related to 100 and 10% related to 50? So now we're using that 10% box, comparing it to the 50 and the 10. You can state that comparison. Kira? Excellent. So there are 10% in 100%, and 5 10% and 50%. You guys make sure you have this written down. See, some of you that haven't moved your pencil at all. That's probably not a good thing. Any questions on any of these relationships? Okay? So just as a side note, these are the same kind of our benchmark fractions of 0, half, and 1. Half would be the same as 50%. 1 would be the same as 100%. Let's go to our next page. So continuing the pattern from the tape diagram, how is 5% related to 10%? So what does that relationship look like? Autumn? So what's that relationship? Did you see how we phrased the last three? Aubrey? There are two 5% and 10%. How is 1% related to 10% and to 5%? So now it's actually not in our tape diagram anymore, but you should be able to think about this one. How are these two going to work? What do you think, Leah? I'm sorry, I distracted you from your conversation. Legend? So how are they related? Okay, so there are 10 1% and 10%. And then what about 5%? Aubrey? Good. There are 5 1% and 5%. Is this making sense so far?
Yes.
Okay. So now we're going to start using these benchmark percents to show you how we can start making calculations off of them. So we're going to determine each value if 600 is 100%. In other words, I'm looking at these out of 600. So in other words, if I want 50% of that, we just said there's two 50s in 100, right? So what number would I double to get to 600? 300. See how we're doing it? So you got 4 more to do. Those of you who are feeling really good about this, you can start doing number 4 as well. But we're going to go over that. We're not going to give you a calculator because that one should be relatively easy. And once we go through it, hopefully you'll see that. But for now, finish up these 4. We'll give you guys about 2 minutes to do this. Okay, guys, I'm seeing a lot of confusion on this. The whole deal with percents is understanding these baselines and how they're related so that I can rapidly get to my answers. The whole idea is you should be able to do this very quickly, especially with even numbers like this. So I have 25%. We just did that whole listing of percents, right? I also know 2 25s is 50%, correct? So I can take my answer from 50 and divide it by 2. I know that's 150. Or you could have said that's 4 25s gives me 100. So 600 divided by 4. Either one's going to get you the same answer. One of the beauties of understanding these baseline percents is you can do whichever one makes you feel most comfortable. Now my next one, I'm going down to 10%. So for this one, I'd go back to the original. And I would say, okay, I know there's 10% in 100. So what number would I multiply by itself 10 times to get to 600? Another way to think about that when I'm doing 10% is I'm just moving my decimal once. Now I'm down to 5%. So here I know there's two 5% in 10%. So half of 60 would be 30. Going down to 1%, now I can go all the way back. So I know there's 100. 1% is 100%. So I'm moving my decimal twice now from the 600. 1, 2. It's going to give me 6. Or you could have said there's 5 ones in the 30. To get the 5%, divide that by 5 and get 6. Any of those work? Does that make it any more clear for you guys?
Yes.
How many of you are still struggling on these? I'm not seeing any hands. I'm seeing one hand. Thank you for being honest. Couple. Now we're seeing a few more. Okay, let's take another look. And we're not even going to use a calculator because honestly, because I'm doing 1% and 10%, I don't need a calculator. Percent means what?
100.
Out of 100. So if I moved from percent to decimal, how many times am I moving my decimal? Twice. What if I'm doing 10%? Now how many times am I moving my decimal?
3 times.
Once. Because in 10 there's 1 0, right? What if I'm doing 1%? 2, because now I'm going all the way down. So if 28, I'm looking at 1%, I need to move my decimal twice. That's 28 hundredths. Because I'm finding 1% of it, 1 out of 100. That's moving it twice. If I'm doing 1% of 234, it doesn't matter where my decimal is, I am moving it twice. 2 34 hundredths. 1% of my decimal, it doesn't matter where my decimal is, I'm moving it twice. Going 1, 2. And the buckets get a 0. 0.00, is that a 3 or an 8? Looks like an 8. 1% of 5 86 hundredths. I'm moving it twice. Empty buckets get a 0. 1%, I'm moving it twice. 10%, how much am I moving it? Once, because now it's only 1 0. So now I'm just moving it once. 2 8/10. 23 4/10. Once, that 0 now comes after the decimal. Once, the 5 is now after the decimal. Can you see how this becomes easier? Doing 1s and 5s. Or 1s and 10s. Literally, guys, all you're doing in these cases is moving my decimal place. Okay, so write a rule to calculate 1% of any number. Move my decimal twice to the left. Okay, have a good day, guys. Happy Valentine's Day. No homework for today. And for 10%, move my decimal once to the left. Good luck. No homework.